Happy Dasara to everyone. Okay, let us begin my today's video, which once again is on center of mass, conservation of momentum. Okay, now this is one more question a student actually asked me, which is on, can we use center of mass to change the direction of motion? Okay, so this is a problem which I took from H.C. Verma. I modified this a little bit. It's a big problem. But what is required, I just put it. Otherwise, the entire space will be filled in. Okay. Now, a man of mass m having a bag of mass m. Don't. I urge you people not to do this experiment. Okay, it's a theoretical question. Bag of mass m slips from the roof of a tall building of height h. Okay, very tall building. I do not know how many feet it is, and starts falling vertically. When at a height h from the ground, he notices that the ground below him is pretty hard, but there is a pond at a horizontal distance x. There's a pond here. Okay, when he is nearby to this particular distance, he notices, okay, he's already nearby to. I don't know. Okay, anybody will notice it because the moment you fall into, you'll say, okay, whoever is there, please rescue me. Right? Okay, so, I think he's a physicist. He wants to do some research on this. Yeah, maybe, okay, fine. So now what should he do so that he can save himself by directing himself to the pond? Okay, so what should he do? Okay, so that he can fall onto it. I just asked this question casually to a student. And the student said, sir, what he has to do is he should act like a Superman. So what is that you can do? So he should lean himself at an angle theta. So what he should do is, so he should lean like this. He should lean like this. Okay, my way of drawing is not so accurate. He should lean like this with respect to the horizontal like this. With respect to horizontal theta here. Okay, maybe I can draw the line here also. I can draw the line here also. So that this theta, so I can now write tan theta is equal to h by x, because I want to know what is the value of theta here, right? From here, this theta, I can find out what is this 90 minus theta. And I can say, okay, so if I do something like this, I can easily fall. Now, do you think this is correct? Something which is shown in the movies also. And as when we were youngsters, we always used to think, okay, if I lean like this, I can easily fall into the pond. But does it happen? No. Gravity says, I am not bothered what is your inclination. My interest is I am going to pull you down, right? Wherever you go, I'm going to pull you down. That's it. Okay. Whether you are tall, whether you are rectangle, spherical, or you are oblate, whatever you are, okay, I'm going to pull it vertically downwards, right? So therefore, this concept is incorrect. We get this concept because we have watched the same thing in cartoons some more young time. That's what I always say to my students. If you are good in physics, okay, you can be a better cartoonist. The reason is because if you are good in physics, you can play with the laws of physics. In cartoons, if you observe, while you make a cartoon animation, okay, you should see to it that the rules or the laws of physics, okay, should not be obeyed by the objects which are falling. If it is obeyed, that means there's nothing new in it. Okay, you don't get that feeling over there. But if it is not obeyed, if it is violated, then definitely you can do wonderful animations. Okay, now let us continue with this problem. Now, what is the answer for this? So this is a question that we have. Now, towards it, what is that you need? The person definitely will fall like this. Now, here he says that you have a person whose mass is m, and there's a mass m here. Okay, so towards it, we have to use center of mass concept. Now, how do I use center of mass concept? Now, what I do is, this person now throws the bag like this. If he throws the bag like this, now what will happen to this person? It is similar to that of using a big ball. There's an explosion. The small part of this ball now get exploded and goes like this. But the larger part now goes like this only. Of course, because of gravity, both of them will be falling like this only. No issues. Okay. But now when I throw when this person throws the bag like this, then definitely he will fall like this. Now the question is, okay, so how should he throw? What do you mean by how should he throw? Horizontally. That's known. Okay. But when I say how should he throw, which means with what velocity should I throw? Okay, with what speed should I throw? Because when I throw it at a given speed, then definitely this person can fall over here. That's the question now. Now towards it, now what do we need here? This is a distance x here. Now let the time taken by the person to start from here and to reach this height, bt. Let it bt. Now let us use our free fall. So what do we have now? We know that t should be equal to square root of 2h by g. 2h by g. Can I use this? No, I can't use it. If I use this as my origin, I can use it. Okay, so I'll consider the velocity at this point is 0. Can I use it? No, I can't use this. I can't use this. Just a moment. What method should I use? Any idea? What has been asked? What should he do? I don't need time and all. What should he do? He should throw the bag here. With what speed should he throw? That's the question we will ask. Okay. First make it simple, then make it more complicated. So let us say he throws it with a velocity v. So this person will also move with a velocity v1 over here. Okay. So therefore I should write m into v should be equal to capital M into v1. The velocity of throw, the way how he throws it, should now be equal to capital Vm into v1 divided by m. Capital M is known, small m is known, but this v1 is not known. How do I find v1? What is v1? See, the moment the person falls over here with this velocity, he has a horizontal velocity and he also has a vertically downward velocity, which means as the person falls, he now describes a projectile like this and exactly falls onto the ground, which is similar to that of the problems that you have already done. I hope you have done. If you are 11th standard student, you would have done horizontal projectile motion, wherein you have a particle here at a cliff, you are giving a velocity. So maybe an aeroplane is moving like this, it drops a bomb, and as a result of it, it falls over here like this. Same problem now. Okay, only thing is it has a velocity downwards also. We have to take care of that also. So towards it, now I can now write, since there is no air resistance, wind resistance in this direction, okay, let it take a time t to reach this point. So I can now write v1 should be equal to x into v1 equal to x divided by t, distance divided by time taken by the person to start from here and to come over here. In other words, x is equal to, or what do I need here? With what velocity? Okay, I can now just write this should be equal to m into m by m into x divided by t. Okay, now the distance x is given, but this time t is not known. Now, how do I find the value of t? That's a bigger question here. Okay, so towards it, what should I do? Let the t be the time taken by the person to start from here and to reach here. Now he started jumping from here. When he came here, his velocity is some u. At this point, its velocity was 0 here. Okay, he has traveled a distance of h minus h. H minus h, right? This whole h, and this is the whole h over here. See, if I add this h minus h plus h will give me total h here. So this is the distance fallen by the person, okay, in a given time t. Okay, don't forget about the t. So I want to find what is the velocity here. So the velocity at this point was 0, but when you reach here, its velocity was u. So what I will do is I will use my equations of motion, okay, for the first half. So which will now give me initial velocity, the final velocity. Final velocity, this is my first motion. The final velocity here is u square is equal to v square. Sorry, v square is equal to u square. What is u square? 0 square plus 2gh, 2g into h minus h. I hope you are understanding this. Okay, now we have u square equal to so much r. Now this becomes u should be equal to square root of 2g into h minus h. This is what I get. Now what happens? Now the person is at this point. Its initial velocity is u. Is describing a displacement h downwards. Okay. So now what is the time? We need to get an expression for time. So let us use s equal to ut plus half t square. So now what is s? If I consider this as my vertically downward axis, then I will say this is h should now be equal to ut. What is u? Root of 2g into h minus h into t. Then plus half g into t square. Okay. So or in other words, let me take this one inside. What will I do now? I would just need to get the find time over here. So anyway, this is constant. So what I will do is I'll write this as at plus bt square is equal to h, because this much big expression, solving it will be very difficult. I do it like this. In other words, now this is a quadratic equation. What is a quadratic equation? Bt square plus at minus h equal to 0. So I can get the value for t. What's the value of t? Yeah, there's no space at all. Huge problem. So I can get the value of t. I don't think I will solve this. If you want, I can do this. T is equal to minus a plus or minus square root of b square. What did I do? Minus b, I'm sorry. See, this is a mistake we make. Minus b plus or minus square root of a square minus 4ac minus 4 into b into minus h, which will be plus 4bh divided by 2b. Okay, so we just need to plug in what is the value of a value of a. Where is the value of a? This value of a is value of a, and what is the value of b? B is 0. Okay, so now when we plug in these values, we'll get an expression for t. Take this value of t and substitute here. I'm not solving the whole problem. If you want me to solve, how much time does it take? Because the video will take a long time. Student retentivity will be much lesser. Okay, so now b. What is b here? The value of b is half g. Okay, minus g by 2. Minus g by 2. Am I doing it correctly? Yes, minus g by 2 plus square root of a square. What is a square? A square. A is so much. This should be square root of 2g into h minus h plus, once again, plus 4 into b. What is b? B is g by 2. G by 2 into h. So these two ones are 2's are divided by 2b. 2. What is b? B once again is g by 2. G by 2. So when I do this, this will be 2gh, and here I have minus 2h, 2gh, so it will become plus 2gh. So I will get the answer as minus g by 2 plus or minus square root of 2gh divided by g. Okay, this is what I get. Then I can simplify it. I get an expression for this one. I can substitute this value and get the final answer. Okay, so this is how you can solve this problem. Now, what is the concept we have learned here? The concept that we have learned here is that we can shift our direction by using the center of mass. You throw it at this given velocity, v is equal to m by m into x by d. I would be able to find out, okay, with what speed should I throw the bag horizontally so that I can fall. I can fall in the horizontal direction like this. Now, while doing this, one more interesting question I got is that, sir, why do I need to throw the bag like this? Why can't I throw the bag upwards like this? Now, think about it. Okay. So if I throw the bag upwards like this, will I be able to move like this? Definitely you can move. Okay. But the problem now is you have to throw it against gravity. It will not be so effective. Okay. So here itself, you need to throw it with a very larger velocity. Okay. So if you are throwing it like this, the velocity will be much, much larger. Because a part of the component will go like this, part of the component will be much here like this. And since you are applying a force like this, when you're applying a force like this, then you will fall faster over here. So definitely you will not fall into this, you will fall on the hard ground. So the best way is to throw it like this. Okay. Now you can also think what will happen if I throw my bag like this. If I throw it like this, then I will be pushed upwards, right? I will be pushed upwards. So I may be able to describe a projectile motion like this and then fall into it. Is it feasible to think about it? Okay. So think about it. Let me know about it in my next video, or maybe you can add it in your comment section. Thank you very much for watching this video until the end. So I think I have one more or two more problems on center of mass. And after this, I have not thought of what problem should I start with. Anyway, I have been getting replies from you guys. Thank you so much. But let me think. Maybe I can start with rotation. I think rotation would be better. Okay, rotation or gravitation also I haven't done. Let me see. Okay, if I have some interesting problems, I will definitely proceed with the gravitation ones. Thank you friends for watching this. Like, share with your friends and subscribe to this video, to your channel, so that you get more updates about it. Thank you.